We're really excited to share with you some best practices and insights for how you can get started with metal 3D printing. We know a lot of you are probably already familiar with the world of 3D printing, whether through plastics or composites or other materials, but taking that next step to metal can be a little bit daunting. So we're here to answer those questions, dispel any thoughts that you might have, and just really help you feel confident and courageous about taking that next step. We brought our partners from Exact Metal on to join us for this webinar, as well as an educator. So taking a look at today's lineup of panelists, again, I am your host. I will be moderating today's discussion. And then we have our friends Dave and Abigail from Exact Metal, again, our partners with metal 3D printing technology. Andrew Buckland has joined us from New York University to kind of talk about how they're implementing this technology at that university. And my colleague Nick Moots from Lab Midwest will be wrapping up our discussion today, helping you envision how this technology could work in your own program, no matter where you are or what you're teaching. So before we get started with our official programming, we want to run a couple of polls for you. So I'm going to launch these polls. You should see those popping up right now in front of your screen. And it's just kind of asking you about your experience with 3D printing technology. So if you can just take a moment to answer those poll questions, I'll give it about 60 seconds or so, and then we'll end the poll. Perfect. All right, I'll share those results with everybody. So no surprise there that everybody has already, dived into the world of 3D printing in some way, shape, or form. Glad to see that some folks have gotten into metal 3D printing, and really, really great to see that a lot of you haven't. So that's what we're here for, right? To help you take that next step. So thank you for sharing your answers. So now when it comes to how to get started with metal 3D printing, what's the technology like, and all of those fun questions, I'm going to hand it over to Dave Jankowski. Dave?
Great. Thank you, Melissa. What I'd like to do in the next 15 minutes is to give you a little bit of background on the technology involved with metal 3D printing, talk about some facility requirements, typical applications, and then close talking about 3 specific educational institutions who have adopted metal 3D printing. The technology I'm going to focus on is called metal powder bed fusion or laser powder bed fusion. The technology essentially consists of using a high energy laser to melt a thin layer of metal powder, and then to do that sequentially over and over again. What you're looking at now is the interior of what we call the build chamber of a laser powder bed fusion printer. On the left side, you see an item called the feed chamber. That is essentially lowered and filled up with metal powder. Metal powder, steel powders, inconels, aluminums, titanium, copper, cobalt, chrome, and so forth. Essentially, any metal which you can weld, you can print, because this is essentially a micro welding process. So the left-hand feed chamber would be lowered. You would fill it up with powder. And then the recoater would move across the feed cylinder and take a very thin layer of powder. By thin, we're talking 30 microns approximately, and spread it onto the build plate. At that point, a high energy laser would then be activated to outline the shape of the component which is being printed. And then the process will be repeated hundreds of times, even thousands of times for some very tall applications. The real key to remember here is that the metal has to be weldable in order to be printable. Secondly, you have to use high quality powder that has a very narrow powder size dispersion. What we're going to show you next is essentially a more detailed example of the process being performed. Again, as you can see in the left-hand photograph and the figures on the bottom, We have the powder feed cylinder, which is being lowered. The recoater, you can see in the green photograph there, it's on the right-hand side. That is what spreads the powder onto the build cylinder. And then in the right-hand photograph and figure, you can see the high energy laser being active. And in this case, tracing out the name of a product called XM200G. And again, repeated over and over and over again. The beauty about this technology is that as printed, the part has over 99.5% relative density. So what that means is you can treat it as if you had machined the component out of a block of metal or a block of steel. If you would typically heat treat it, you can heat treat it then. If you typically heat treat and finish grind, you can heat treat and finish grind. In addition, the as printed dimensional tolerance is plus or minus 0.2%. So that kind of equates to better than rough machine, but not quite as good as finished machine. And as you can see here, some components can be used directly off the printer. This is a great example here of these three photographs. You know, this is the inside of the build chamber. In the left-hand photograph, you can see a part in the build cylinder. You can see some powder surrounding it. So what will be conducted next is you would use a vacuum in order to remove the excess powder, which can then be repurposed and reused. So that's another advantage of this laser powder bed technology, is you don't have a lot of waste. Any powder you do not use for a specific part, you can remove, re-sieve, and then replenish the feed cylinder in order to repurpose the powder. The middle photograph, you can see most of the unused powder being removed, the build plate being raised up. Since this is a micro welding process, the part is physically welded to the build plate. So what that means is after you remove the build plate from the printer, you would have to cut off. And in this case, in the right-hand photograph, you see a bandsaw being used in order to cut off or remove the part from the build plate. The build plates are reusable. You would simply use an angle grinder, for example, to knock off any little remnants of the supports that remain on the build plate after the part is being cut off, and then just simply reinstall it inside the printer. These build plates can be used hundreds of times. And what's super cool about this application is what that part was. It's essentially part of a custom muffler or exhaust system for an old Chevrolet. It's kind of a cool, fun application of the power of this metal powder bed technology. You know, the moving over to the next slide and so forth. Let's talk about the facility and safety requirements a little bit. You can see on the right side, this is a installation of one of our end customers. In terms of the facility, one of the nice things about the printer is the small footprint. You know, the footprint is a little bit more than 2 feet wide by like 2.5 feet deep. It is designed to fit through conventional doorways, which means it's easy to move into a room, easy to position, and easy to integrate into an existing facility. It uses standard single-phase power, either 120 or 230 volts, depending upon the level of laser that you're using. We do use a inert gas, such as argon or nitrogen, to flood the chamber. What that does is, during this metal laser powder bed fusion or micro welding process, you don't want to form any oxides. So this inert gas, this argon or nitrogen, which is injected into the build chamber and it flows across the build plate, it ensures you don't generate any oxides during the actual printing process, which could detrimentally impact the properties of the component. The gas also has a second use, which is to remove away any spatter that forms during the actual process. That is termed sucked away and then removed through some internal filters. A couple cool things about this photograph. Again, you can see the printer, you can see 3 happy users and one of our installation techs. You can see the floor. It's not a carpeted floor. You don't want to use carpet because if any excess powder falls in the carpet, it can be inconvenient to remove and so forth. And on the other hand, it doesn't have to be like a certified clean room. That's one of the misconceptions about this laser powder bed process. I'm sure when Andrew walks through his use and so forth, you're going to see kind of how he uses it in a clean environment, but it doesn't have to be a clean room sterile type environment. Next, let's talk about safety. Because you're using a metal powder, as with any process, whether it's powder coating or even welding, you don't want to inadvertently inhale that metal powder. So in this case, we're using a positive pressure respirator while you're pouring the powder into the printer and after the print while you're removing a part from the printer. It's a very quick process. And in relation to the whole printing cycle, it's less than 1% to 2% of the entire printing cycle where you have to wear the respirator. Again, it's just to ensure you don't inhale any metal powder. You also have to wear latex gloves because you do not want to track any powder out. You don't want to take any powder home with you, for example. Again, the powder itself is not going to be harmful other than if you ingest it accidentally. A Class D fire extinguisher is required. That's for powdered metal use and so forth. And any excess powder or waste powder, you would have to dispose of in a specific powder container, which can then be hauled away by a waste management system. The cool thing about this technology, because you're 99.5% dense, which means you have great mechanical properties, because you have good as printed dimensional tolerances, because you can then process the part as you can with any other metal part, is very useful in a number of different applications. And here you can see 4 of them specifically. The one on the far right is an application with a ball screw company out of Eastern Europe. They used the technology and the design capabilities of the laser powder bed fusion printer to come up with a easier to manufacture solution for a very critical application. You can see the kind of little part there and so forth. That is actually installed inside the ball screw, and it allows a different tool path. It could not have been done with any conventional type of machining or subtractive machining processes. So laser powder bed gives them that capability. Now, as always, with the design changes and so forth, typically you don't hit it right on the nose the first time with the first design. And any additive process, specifically laser powder bed fusion, allows you to do these rapid design changes. So you do a design, you print it, pull it out the next morning, decide that you want to further optimize the design, you simply update the CAD file, pull it into some design software, then upload it into your printer. It also allows for local production, which means that you can produce it on site. You don't have to send it out if you don't have the internal capabilities to do it, because the machine is so accessible, so integratable, and so affordable. Second application is what we call on-site production. This is a cool part. That little funnel there, which you see below that handle with the blue knob on it, that is actually used in our XM200G printer. Our company, Exact Metal, is the perfect customer for a low production, high mix, or high design content application. We print the component in-house. We can rapidly customize it. if we come up with an improved design change. It eliminates any lead time because we do it all in-house. And frankly, most importantly, it saves us over $200 per printer to print that in terms of cost, to print that funnel rather than purchasing it from the outside. So for on-site production of small quantity custom runs in industry, super critical. And I'm at a conference this week, and I've had a number of discussions with military folks where they have parts in the field or assemblies in the field where they have to get replacement parts quickly. And they're considering having printers installed locally in order to print the component real time. The third picture, the challenging geometry picture, we just like this picture because it shows the fine detail which you can produce with this technology. You know, you can see the parts there. The actual thickness of those parts is about 200 microns, very, very thin. So it allows you to produce very thin parts very consistently, and in this case, in a pretty large volume. The additive technology also allows you to produce internal features. One of the cool things there is, you know, you can produce something internally like a conformal cooling channel in a tooling component. And talking about tooling, you know, tooling is another great application for this technology in that tooling is customized most of the time. It allows the components to be rapidly designed and then produced, to allow optimization of the fixturing, reduces any machine downtime because you're waiting for this tooling to be machined. So these are 4 typical applications, which then lend it to kind of where it kind of comes into play for educational institutions such as all of you represent. You know, metal powder bed fusion in general has really taken off in the last 5 to 10 years. It's been following plastic 3D printing. Laser powder bed fusion, because of all of the capabilities that we've talked about, great as printed density, very good dimensional control, easy integration into your facility, and affordable price, you know, has led it to being used by more and more large companies and industries and so forth. Companies like Medtronic, Siemens, GE, and so forth are using this technology. So what that means is they need technologists who understand the technology, you know, who can go in and help them implement this technology. And that's frankly where all of you fit in, as Nick is going to be walking through. You know, it just, you know, you have to prepare your students in order to be able to effectively discuss and use this technology. So what I'd like to kind of conclude with are 3 educational institutions who have successfully implemented laser powder bed fusion over the last 2 years. And then Andrew from New York University, you know, will of course discuss his in a lot more detail. The first is on the far left is Southern Denmark University. I like this picture because you see the smiles of everybody. These folks have been using the technology for about 2.5 years. They use it to support a lot of outside industrial contracts which they receive. In fact, one of those applications Melissa is going to touch on, where they were funded or they were provided some funding in order to develop this new component. And in order to do it, they had to have the capabilities of a laser powder bed fusion printer. The picture in the center is at Origin Labs at Penn State. This is a makerspace where they have a lot of tools. They have CNCs, they have laser cutters, they have 3D plastic printers, and they have a laser powder bed fusion printer. What this allows is that students or local citizens from the State College area who perhaps are thinking about a innovation, or maybe thinking about starting a company based upon a invention that they've come up with, they can actually use the equipment to prototype their solution. You know, maybe they have a part with internal features. They can use the XM200G printer to print that component. Then they can machine it. And maybe they have to laser cut it. Maybe they have a auxiliary component that's plastic 3D printed. So for like maker spaces, I think they're really starting to see the value of enhancing their capabilities by adding metal printing. And then on the far right, Binghamton University up in Binghamton, New York, our colleague there, our friend there, is using it for a research for R&D, where he uses the capabilities. He's added some additional sensors and so forth in order to do some basic fundamental research. So whether it's contract type applications, whether it's in a makerspace with either local citizens or students, or for R&D development, this technology really has a lot of great capabilities. At that, I'm going to turn it back to Melissa.
Thank you, Dave. That was a great overview of the technology. To all of our attendees on today's webinar, we encourage you to ask questions. So if you notice there's a Q&A button on your Zoom control panel there, if you have questions about anything that you've seen so far, any of the technology that Dave's presented on, or anything that you'll see or hear about throughout the rest of the webinar, please ask your questions in that Q&A box. We're going to save them all up for a dedicated Q&A time at the end of today's webinar. But I do encourage you that at any time, you don't have to hold on to them until the end. Just as it comes to you, go ahead and submit your questions, and we'll save them for our amazing group of panelists. So speaking of our amazing panelists, I'm going to invite two more of them to take the stage now. Abigail is Dave's colleague over at Exact Metal, and she will be talking with Andrew from New York University, who we've already teed up a little bit about their specific use case. They've got a great story to share. So Abigail and Andrew, I'll let you guys take it away.
Thanks, Melissa. So I'm very excited to introduce Andrew Buckland. He is a manager at LaGuardia Studio at NYU. And he's been kind enough to share some experience and join us today. So let's start. Andrew, do you mind explaining a little bit more about what LaGuardia Studio is and what your position there is?
Yes, so I'm the manager of LaGuardia Studio here at NYU. As my title suggests, I'm also the technical lead. So I do a lot of the actual research around equipment that we purchase. The studio itself is a centralized service bureau for the university. So we service the entire university across all additive manufacturing style technologies and 3D scanning.
Gotcha. That seems like a big job.
It has its moments. We can be quite busy. Those of you at universities know that when you're centralized, everyone is your client. And we see people from all around the university, whether it's in medical school, the hospital, engineering. We have 2 art schools. Believe it or not, artists love to use this type of technology. It's one of the uses we use our metals printers for. Actually, the most at the moment is making artwork.
That's cool. So you were already in plastic printing, right? Before you transitioned into metals. So I'm curious, there's multiple different ways to do metal 3D, different technologies, different methods that all have their, their positives and their drawbacks. So I'm curious, without getting into too much detail, how you decided to go with powder bed.
So for us, we've been watching the metals, I'm just going to call it the metals market for a while, reviewing equipment from different manufacturers, different styles, whether it be FDM style metal that has to be centered, or binder jet style metal also needing to be centered. And then we're looking at the laser based systems. What really came down to us was size. We do a lot in a very little space. So we were able to get 2 systems and fit them in. That was a big selling point for us. And then the vendor's commitment to willing to share information is another huge one. We don't like to work with vendors that don't have a positive relationship sharing information. So.
Gotcha. Definitely makes sense. So once you got into that, can you walk us through that journey a little bit? Like evaluating the different things that were going to matter, right? Like your staff, your space, any safety things that may have come up.
Yeah. So the biggest thing you have to do is decide what materials you want to print in. That's a big driving point. And obviously you need to poll your communities and see what they want. I know from my experience, the very first thing out of people's mouths were titanium and aluminum, which by the way, we don't do. But we ended up settling on stainless steel, and we have some Inconel material. And that fits a broad range of the client needs. Okay, so that kind of led us into the material type. For the actual system, we needed to know that the material was going to have a very high density. Some of these processes, density is an issue. So that kind of led us towards the laser-based systems. And then obviously we all have budgets. Budget is part of the discussion and what sort of bang for your buck can you get? And then quality and vendor relationships led us all down the road to choosing exact metals over some of the other technology types. A lot of laser-based systems are just not accessible when it comes to price. And we found the price to be very friendly in this department for this style technology. And then as what you're seeing on the screen here is actually the construction process of our room that we were honestly doing this time last year. We chose to put it in a room because, like I said, it's a very small space. We have 2,000 square feet spread across 2 floors, and we have 2 types of every system we have. So we needed to make sure that we could stick the machines in this space and not impede the hallway, so you could walk down the hallway. The nice thing is the enclosure is all glass now, so you can literally stand and observe the operator from a foot away.
Oh, gotcha.
One of the benefits. So.
Very nice. When you mentioned that you guys don't do aluminum and titanium. I kind of want to just highlight that quickly. That I'm assuming that was a decision that you made based on the facility requirements and just the additional cost that could bring, or was it also a safety element potentially?
So safety was a big concern when we brought metals on the campus. We spent a lot of time educating our environmental safety team about the process. So that was part of the reason why we couldn't do titanium and aluminum. They felt very uneasy about those materials because of the additional layers of safety that you have to do. And then the requirements of the city itself to run those style systems became cost prohibitive to set up the facility. So.
I see. What was the conversation like in terms of safety aside from those materials? I recall you saying that you had to do a little bit of proof to your point in terms of how safe this technology really would be to implement, because there was some nerves around implementing metal.
So yeah, there was quite a bit of education that we had to do. We found our health and safety team doesn't handle 3D printing. They don't have any experts in the field. They don't know much about it. Mm-hmm. So when we came to them to set up our proper procedures, because you're supposed to work with these people for procedure setting, they just immediately ran out on Google and basically clicked on the first link they saw about metal 3D printing safety, and it scared them. What we did is we actually broke down all of the processes for them, built a flow chart, put a reference out to how long that you would be in the papper, how long are you exposed to powder, what are the procedures around cleaning, are we going to allow students to use the printer directly, or is it going to be an engineer using it? with the assistance of a student employee, or all of that went into the case. So there was a lot of dotting your I's and proving, but you got to walk into the situation with all of the answers so you can stop before it scares them.
Yeah, that definitely makes sense. When you were going through that evaluation process, was there anything that caught you off guard? Any regulations that may have been surprising or easier or more difficult than you had anticipated?
For the metals that we picked, the regulations are very simple. A lot of it has to do with waste disposal. So here in New York City, they require our hazardous waste to be tested. So we had to get an analytics done on the actual waste that we're generating. So stuff like that. That surprised me. But around the general setup, you just want to make sure you have proper heating and cooling, and your airflow is not too heavy in where you're working with the printer directly. That was the other part that caught me a little off guard. So
Gotcha. Nice. So now that you have 2 machines installed and up and running, do you mind sharing a little bit on some applications that you guys have been doing ever since you got it up and running? I'm curious about the art, but also anything in more the industrial sector or anything like that.
yes, so I have a variety of prints. I'm going to try to show you some different things. Some of it is kind of scientific based, some of it is engineering based, some of it is actually us trying to push the limits of the printer.
Yeah,
So
sure.
this kind of falls into the art realm. Let's see if we can hold this little guy up.
I can't see your video.
We know you can't see my video.
Let me see. There we go.
We can see it, yeah.
There we go. So we wanted to know, because with plastic printing, you can print things that move, right?
Mhm.
So we wanted to figure out how to do it with metal printing. Not easy, but it can be done. No post-assembly. So we did in-house testing, stuff like that. Believe it or not, researchers sometimes ask you to print the weirdest stuff, even when you can get it from places like McMaster. So, you might end up printing custom gears because they don't like the material type, or they think it's going to be faster or better, or sometimes they need something that's just very particular. So gearing for different types of mechanisms. Pretty straightforward. These gears were actually, you see how shiny they are in the light. They've been faced in our mill. So it's one of those additional tools that are handy to have if you are doing this, because without that, you have a dappled surface. And if you're on another surface, you get a little friction gain. But yeah. Other industrial applications. This is a culminator for exhaust manifold for custom car. We see all sorts of fun stuff. And then in the scientific realm, we've done quite a bit for neuroscience. I don't have any products to show you in that realm, but they really like the stainless steel because it can go in the autoclaves and it doesn't contaminate their research because they can keep it clean. And then, the other fun stuff. This is actually on a plate. We built this as a storytelling method to explain to our client base how the process works. So we can talk about supports, what it looks like out of the printer, and then what a little post-processing can do for you. So that's a megalodon shark's tooth from a project we assisted with at the New York Natural History Museum.
Oh, very cool. I was curious where that tooth came from.
Yes.
Gotcha. So what did your students or the people, anyone that's running the printer, what did they think in terms of the post-processing whole deal? Did they find it to be challenging, or was it easy to pick up?
That is a good question, and that's a hard question to answer because we all have different background sets. So me personally, I have a background in metalsmithing. I found the removal and post-processing to be very, very simple and easy. Having said that, disclaimer, I know my way around a bunch of different types of hand tools from doing metalsmithing.
Makes sense.
My colleagues that don't have any metalsmithing experience, it's taken a little bit more of a learning curve because you've got to learn some of those basic processes. But overall, it's pretty easy. So,
Gotcha. So it wasn't a huge roadblock for anyone.
not a huge roadblock. It's helpful if you have a little bit of training on how to use hand tools before you dive into it. So.
Yeah, definitely makes sense. Awesome. Well, is there any other parts or stories you'd like to share with us? I appreciate you bringing the ones that you had.
Those are all of my parts that I brought into the room with me today. But yeah. So overall, we found the systems to be very successful so far after rolling them out. If you are doing just stainless steel, it's a great material to get used to. And the benefit of it is you can use both argon and nitrogen with it. So you have gas options. I just wanted to point that out. We did recently have an argon shortage. So you are sometimes at the merry of the worst of the world. So.
Gotcha. Yeah, that's definitely a good point. We try to keep things as open and accessible as we can, and I'm glad that it's working for you.
Yes, the systems are quite accessible. So
awesome. Well, thank you, Andrew. I'm going to pass it over to Nick, and I think he has a few more stories of other universities that are looking into this technology.
Yeah.
And while Nick is getting his screen all set, I will just say thank you, Andrew, for participating. Those were some incredible parts that you shared. And they're really a broad spectrum of applications, really fascinating. And Dave teed this up, but we are going to be sending everybody the Southern Denmark University case study in a follow-up email. So you'll get access to details about that entire story. You'll get access to how they partnered with a local industrial employer to redesign one of their parts that was traditionally machined. And, you know, Nick and I are here in Wisconsin. This is like the machining capital of the country. A lot of machining companies out there, but have certainly limitations to the process. And there's ways that the metal 3D printing can come in and do redesign and maybe create some more optimal parts for those companies. So Southern Denmark University was able to do that with one of their industrial customers, was able to make a more efficient, a more cost-effective part, and not just prototyped part, but an actual end-use part for them. So all the details in that follow-up email. Again, because we're recording this webinar, everybody who signed up for today will get that recording in an email coming later this week. So keep an eye out and we'll include that case study. All right, now over to Nick.
Thanks, Melissa. My name is Nick Moots. I'm with Lab Midwest. I'm their director of higher education. If you guys aren't aware of who Lab Midwest is and what we do, we are the Midwest's largest distributor of curriculum, e-learning, and training equipment. We are extremely diverse, and we're really excited to partner with Exact Metal on the metal printing aspect. But I did want to provide just a little bit of overview too in terms of the different programs that we work with. I'm a visual guy, so I did some little snapshot videos of different programs we work with. Not only are we really diverse in terms of different programs with robotics, materials testing, mechanical design, welding, but we're everywhere throughout the Midwest as well. We focus on different levels of higher education between two-year colleges and universities. We're really excited to partner with Exact Metal because they're not really pigeonholed into one program that we partner with. They can fit into multiple and almost every single program from a higher education standpoint that we do work with. Mechanical design, prototyping, designing. A lot of our programs we work with right now do plastic printing, kind of like our quiz that we did at the beginning of our, but now we're starting to look at getting into metal printing as well. Some of these that I have up on my slide with our examples, you do have essentially unlimited potential when you come to metal printing. But I wanted to kind of show you guys what different aspects there are for different programs. So again, mechanical design, prototyping and design, materials testing and structural testing, A lot of our mechanical engineering or materials engineering programs will do some type of metal testing using CNC and welding. But the metal 3D printing is another great application for that. Exact Metal is as well because of all the different metals that you can focus on using their printers. Robotics, automation, and mechatronics. A lot of our programs here in the Midwest, they do some type of designing with end-of-arm tools or robotic rippers. Having a metal ripper will be much more durable than the plastic ones that we've seen out in the field. Additionally, a lot of our programs in automation have senior capstone projects, kind of like the one you see on the bottom right-hand side of my screen. Shout out to Madison College. This is their picture here. But they will actually go through and design their own complete robotic and automation cells. This would be an excellent fit for those type of programs that are out there doing 3D printing, additive manufacturing, welding for these type of cells. Drones and autonomous vehicles. A lot of our programs that focus on drones are building and designing their own systems. In education, drones are meant to fly, but they also do crash quite a bit as well. So having some durable metal components on those systems is an excellent fit for those programs. Machine tool and welding technology do a lot with metals already, but combining the CNC machines and welding technology with the additive manufacturing aspect, you can get some amazing custom parts in your metals program. And then Fab Labs and maker spaces do a ton of awesome things for their local industrial partners and supporting their local industry. But incorporating additive manufacturing into the maker spaces, it's another way you can support your local industry. Tapping into a little bit also why we're excited about this technology is the trends that we're seeing, an increase in demand. I went through Indeed this past week and just typed in metal 3D printing, and I came out with 205 jobs just in the United States as of Monday. And what I was really amazed about was the diversity of the job titles. It kind of relates back to how we can fit the additive manufacturing, metals printing into our educational programs. I did provide a snapshot of that as well. So you see here, there isn't just one specific title. You have from CNC operators to engineers to technicians, even to safety managers, that they want some type of metal 3D printing experience or background for these jobs. And then tying into that from a market size standpoint, as of last year, the 3D metal market size was at $6.36 billion. However, by 2030, we'll see that hit 35 billion. Just kind of showing that not only is this technology becoming more in demand, but we're going to see it broaden out to other fields. And that's why we're so excited about not only metal printing, but exact metal. And us as a group at Lab Midwest, we're really excited to see where our educators use this technology with their students.
Awesome. Thank you, Nick. Nick is a fantastic consultant to our higher education partners here in the Midwest. And if you're interested in this technology, you'll get to have a face-to-face meeting with him soon. But before we wrap up, I want to take some time to go through Q&A because I know there were some questions that came up during today's webinar. And I want to make sure we answer those in the time that we have remaining. The first question I'm actually going to ask both to Andrew and to Dave, get to a little perspective. So the question is, what's the learning curve for metal when you've only had experience with plastic 3D printing before? So Andrew, I'd love to hear your experience, and then Dave, maybe on a broader perspective, what you've seen from your customers kind of all over the place.
So yeah, I can take a stab at that. Since we were only a plastics facility before picking up the metals 3D printers, there is a little bit of a learning curve, but it's more for us, it was more about getting comfortable with the process. The actual steps are really easy. It's you get in a mental game where you find you're convincing yourself things are harder than they really are, type situation. But the steps, if you've ever worked with an SLA, are very similar. You're removing the supports in the same way, similar tools, even though it's metal versus plastic. But yeah, it's relatively easy in my point of view.
Yeah, I'd like to support Andrew's comments. We find folks who have done plastic 3D printing have the mindset for the design for additive aspect for 3D printing. There are a few kind of nuances going from plastic design for additive to metal, but it kind of make logical sense. And then the next step, obviously, is when the part is printed, and Andrew walked through this in a lot of detail. We're moving the part from the build plate and then kind of removing the supports and so forth. That takes a little bit of work. We actually find, frankly, the ideal candidate for this technology is a really goes to full range from folks who don't have any 3D experience to those who are doing 3D plastic, have an internal machine shop, and really anything in between. And it really is just based upon, is it a big step or a baby step based upon your background.
Awesome. Thank you, guys. Great question. Thank you for answering. Another question. Dave, maybe you can speak to this one. Is there a benefit to choosing argon versus nitrogen, or any thought process there?
Yeah, really, because we sell these printers on a global basis and the technology is used globally, a lot of times it comes down to the use or the accessible and the cost of the different gases. There is a concern with different kinds of metals when you're doing the processing. If you use nitrogen, there's a chance you can form nitrides, for example, in some specific materials. But, we kind of really find that folks in general, they like to go with nitrogen because it is a lower cost, but doesn't have quite the material flexibility as argon has. We also find it really is kind of a price perspective too, or cost. I found out that our colleagues in Scandinavia, the cost of nitrogen is like 4 times the price of argon. So they go with the less expensive gas. So depending on the material, argon is good for everything. Nitrogen, you have to be a little bit more selective on the metals that you print, and then the price point of the gas.
And that brings up a great point to everybody in attendance. If you want to go down this route, like we are here, both Lab Midwest and Exact Metal, to hold your hand through the whole process. You are never going to be alone in any of this, trying to figure this out for yourself. Exact Metal has just incredible engineers and technicians on staff who can answer any question that you have and walk you through every part of the process. And Lab Midwest, we're here always to answer any questions any time of day or night, and we'll be there to help you out. So this was answered in a little bit different sections, but I don't think we actually kind of listed out what all the different metals that you can print on. Dave, I know you mentioned anything that you can weld, you can print, but can you give us kind of a sense for what those metals are?
Kind of the standard list of metals that are typically printed with this technology are 3/16-ounce stainless steel, 15.5 stainless, 17.4 pH is a precipitation hardening steel used in ordnance applications. For a tool steel, there's a material called M300. It's a Malaysian tool steel that gives you very high heat-treated hardness, as other typical tool steels do. Cobalt chrome is used for a lot of dental and medical applications. Inconel 718-625, a great material to print. Aluminum and titanium, that does move kind of into what we call the reactive range, where you have to have additional features in place due to safety considerations. In general, and somebody new in this technology, even if they want to print perhaps the more challenging metals, start with 316. 316 has a very low price point, so it's inexpensive, it's very forgiving, it's great to learn on. I know that Andrew mentioned, in fact, I saw on the little stickers behind him on his machine, he has a 316 and an Inconel. And I mean, 316 is really great bread and butter material to start with.
That's great advice and exactly what our attendees are looking for. So thank you for that, Dave. Couple questions on the actual printing process, maybe some clarification points. Dave, in regards to cleaning the build plates, are imperfections created using a flap disc okay? And how do you recommend cleaning build plates?
Yeah, that's real straightforward. In fact, I would like to hear some comments from our friend from the New York University too. It's, again, you have the build plate, you print the part, you cut the part off, and you might have like some little nibs thick enough. You put a angle grinder on there. Let's say you put in like a little dip. It really doesn't matter because when you spread the powder fills it in. And you just keep, using a plate. We were probably using plate maybe 40 times and 50 times, and then surface grind it a little bit, and then use another 40 or 50 times. But I'll be interested in Andrew's comments too, because I know he's using those machines a lot.
Yeah, so we're a little different. We actively try not to make dust, so we don't use an angle grinder. We face mill all of our plates after every use. Just skim it, take a little off the top, generally just knock the supports off. But that's only because we're trying to limit the amount of dirt we generate in our space.
That makes a lot of sense, Andrew. I know you've been using printer for a while. I mean, how many plates do you typically have kind of in circulation between the two printers?
Be honest, I get lazy sometimes. I have a stack of 12 plates that need refinished. So, typically, I mean, when it's like humming and we're got a good groove and all the machines are going, we have 4 or 5 plates in service, and we're just rotating it in between the mill and the machine. So
cool.
Perfect. All right. Can you expand a little bit more on, Dave, on the disposal of the powder?
Yep, you just really have to look to see where your local regulations are. I can speak for central Pennsylvania, where we're based and so forth. The cool thing is the majority of the powder can be recycled and repurposed. So you print a part, you have excess powder because you don't use it all. You remove it with a vacuum, a special powder metal vacuum, you put it through a sieve and stuff. But if there is any excess powder, perhaps, which is caught in the filter, in the ventilation system and so forth, you would have to dispose of that filter in a compliant container and then arrange with a local waste hauler to come in who understands how to dispose of powdered metal. And he would be specific on the type of metal, obviously. We're kind of fortunate we're adjacent to Penn State University, so we're just on their contract. So they can come into the chemistry lab to pick up their chemical stuff, or they go to the machine shop and they pick up the machining scraps and so forth. They come by and they pick up our 55-gallon drum. We're currently running anywhere from 3 to 7 printers on a pretty much a 24/7 basis for development and everything. And it takes us a while to fill up one of those drums, I think about 8 months. So it isn't like you generate a lot of waste material, a lot of waste powder, but you do have to have a plan in place. I liked Andrew's comments, with this technology, make sure you kind of suss out everything ahead of time, obviously. Talk to the environmental health and safety folks. And I know that, when Andrew was looking at this technology, I know he spent a lot of time working on that, get everybody involved, so there aren't any surprises, and, discuss the safety aspect, discuss the waste disposal aspects too, as Melissa has brought up.
Yeah, you mentioned you guys are running 24/7 on a lot of your printers. What is the average build time?
Yeah, it varies. From we're doing some parts now, dental parts, they print in about 2 hours. And then we do large funnels and parts that, key thing to keep in mind that the time is dictated by the height of the part, because you have to respread the powder, which is kind of the time consuming aspect. So the taller the part, you know, the longer it takes and so forth. We have some prints in there for 24 to 30 hours. I know the large part that Andrew showed. I'd be interested to know what that kind of took. I assume it was built on end and so forth. I assume that had to be 16 to 24 hours, Andrew, or more.
This is a 19-hour print.
19-hour print, so
Much longer in ink and out.
Yes.
That's perfect. All right. So great questions from our audience. Great information from our presenters. I want to thank everybody who attended today for just spending some time with us. I'll remind you to, again, if you want to learn any more, please contact us. Our email is there. We'll get you connected with somebody who can take you to the next steps and get any information that you need. We are going to be sending out a recording of this webinar, and then the other resources we mentioned. That's going to come from that email above, so info@labmidwest.com. Sometimes those go to junk, so just keep an eye out. Send us a message if you don't see the recording, but really happy to have spent some time with you. Thank you to all of our presenters. This was a great afternoon, and everyone have a great rest of your day.